Hi everyone, this is Dr. Nak, and we are going to go over practice exam number 2, part 2. This portion of the exam, yes, you may use your graphing calculator. Alright, so let's go with number 1. Use the intermediate value theorem to confirm that f of x has at least one zero between x equals to 0 and x equals to 5. Okay, so intermediate value theorem states that if f of a and f of b have opposite signs, meaning one's positive, one's negative, then there must be at least one value c between a and b for which f of c equals to 0. Okay, so what I wanted to do was to actually show you on the graphing calculator how to solve this problem to find a 0. However, my other program would not allow me to record it. I don't know why. It kept crashing on me. So I'm going to do the best way I can to guide you through this problem so that you can find a 0 of the polynomial. Alright, so first, of course, you're going to have to turn your calculator on. And please go to mode. Mode is pretty much on the very top of the keyboard. And if you hit mode, make sure that you're in radian mode and not in degree mode. That's the first thing you should check. Okay. And also, you are highlighted under the function. I'm not sure if you see func, par, pol, and seek, but make sure that you're highlighted under the function. Okay, so after you're done with that, hit y equals. And what you need to do is you need to type in our polynomial, which is negative 2 x to the third minus 9x squared plus 14x plus 2. Okay, so I'm not quite sure what your Windows setup is right now, but I'm just going to hit graph. Okay, so if you don't see a beautiful graph, go to zoom and 6, which is standard, hit that one first just so that you get an idea of what the graph is going to look like. Okay, so again, this is the third degree polynomial and the leading coefficient is negative. So I'm pretty sure you understand what the behavior should be. Okay, so when I hit zoom 6, I don't see the tail end of my graph towards the bottom. So what I'm going to do is go to window and I'm going to scroll down to y min. And I'm going to change that into negative 80. Okay, then I'm going to hit the button, graph button again. Then you should be able to see the graph nicer. But anyways, let's find that 0 between x equals to 0 and x equals to 5. So first, what you need to do is hit second and trace. Trace is at the very, very top bar right next to the graph button. So if you go second trace, that should take you to calculate. Okay, so when you get to the calculate, go down to number 2. It says 0. Hit enter. And you should see a function written at the very top. And towards the bottom, it says left bound question mark. And since we're trying to find 1, 0 between x equals to 0 and x equals to 5, if the left bound is already set to be x equals to 0, just hit enter. And after that, you should see the word, it says right bound question mark. So we're looking the 0 between 0 and a 5. So next thing what you need to do is just hit 5 and hit enter. Then what you should see is guess question mark. And right underneath that, you should see x equals to 5. So don't do anything and hit just enter again. Okay, so if you did that, you should see 0, x equals 1.3297385. So that is the value that I'm looking for. So what I'm going to do is write this solution as 1.33. Put an approximate number there. So that's our answer. Okay, now second part says use your graphing calculator to sketch the graph of the function. Show a quick sketch of the graph in the space below and explain how it confirms your result. Okay, so I'm just gonna graph what I see on the calculator here. Please, it does not have to be perfect. So mine looks like this. Something like that. Okay, so that's the graph of it. Now, what I'm going to do is on the side, I'm going to compute f of 0 by looking at the function. So f of 0 is what? Negative 2, 0 to the third, minus 9 times 0 squared, plus 14 times 0, plus 2, which is 2, which is a positive number. All right, now let's go with f evaluated at 5. So that's going to give us what? Negative 2, 5 to the third, minus 9, 5 squared, plus 14 times 5, plus 2. Punch that in the calculator, and I got negative 4 or 3, which is good. This is a negative number. Okay, so what's going on is this. At f of x equaling to 0, meaning when x is 0, our y value is 2, which is positive. So when x is 0, so I'm just going to put here as 0, 2. But either way, it's positive. And when x equals to 5, 5 should be over here somewhere, our value is going to be a negative number, which is negative 4, 3. Oh no, I'm just going to keep extending that. But the point is that we're going to have a negative value. Okay, so with that said, by the intermediate value theorem, the graph must cross the x-axis. And that would be the 0, which what we estimated as 1.33. Okay, so to explain, after you drew the picture, all you have to say is that since f of 0 gives a positive number and f of 5 gives a negative number, the graph must cross the x-axis between 0 and a 5. Okay, so in fact, the graph crosses the x-axis about x equaling to 1.33. So that's our 0. Okay, so I hope you're able to follow how to do this by using your graphing calculator, but if you have any questions, please let me know. Number 2, a cube has an edge of 5 feet. The edge is increasing at the rate of 3 feet per minute. Alright, so now the question is, express the volume V of m of the cube as a function of m, where m is the number of minutes elapsed. Okay, so first, you know my routine. I love drawing pictures just so that I get a better understanding of what the heck is going on. So pretend that that's a cube. Not bad, right? But anyways, let's just go with the, what is it? We were given an edge of 5 feet. So instead of edge, I'm going to call it side, side, and a side. All the sides are the same because we're given a cube. Okay, so first what we're giving is side is starting off at 5 feet. And then another information that we're giving is edge is increasing, S is increasing at the rate of 3 feet per minute. Okay, so let me just try to write this by using notation. So our edge or the side is starting from 5 feet, and then what? It's going to go 3 feet per minute. So I'm just going to call it 3 times per minute. All right. So I'm just going to call this guy. Now notice that I just made this into a function of m. So I'm going to call it, this is S of m. All right. Now let's look at the what the question's asking. Express the volume V of m of the cube as a function of m. All right. So now let's go with the volume. So what's the formula for the volume of a cube? It's side times side times side, so it would be s to the third. All right, but our s is 5 plus 3m. All right, so what I'm going to do is I'm going to replace the s with 5 plus 3m, and then here we go, we're going to have to the third power. Okay, now let's look at it. V equals parentheses 5 plus 3m to the third. So now V is written in terms of m now. So we can call this guy a function of m. Therefore, V of m equals, let me just rewrite 3m plus 5 in this way, to the third power. Okay, so this is same thing as what? 3m plus 5. 3m plus 5. And another 3m plus 5. Okay, I'm just going to multiply this out. So here, if I multiply the first two, we're going to get 9m squared plus 15m plus another 15m, which is 30m, plus the 25. And now I'm going to multiply this by 3m plus 5. Okay, so if I multiply that out, what do we get? 27m to the third plus 45m squared plus 90m squared plus 150m plus 75m and plus, what's the last one? 125. Okay, so we got this. Now we're going to combine the like terms. So here, let me see, only cubed is what? 27m to the m cubed. All right, now I can combine all the m squares together. So here what we're going to get is what? 135 m squared. And then now we can combine all the m's together. So this is going to be plus 225. And we got the constant term, 125 left over. All right, so therefore, our function v of m is that. So let me just box that for the answer. Okay, moving right along. Number 3, use the given information about the polynomial graph to write the equation of the polynomial function. Okay, so what do we got going on here? Zeros at x equals to 1 with multiplicity 2. 0 at x equals to 3 with multiplicity 3. Passes through the point 2, 15. Okay, so let's gather all the information first. So let me just write it as f of x equals some constant a, and then what, zeros at x equals to 1. So here you're going to have a factor of x minus 1. And this 0 has a multiplicity 2. So I'm going to put to the second power. And the next one, 0 at x equals to 3 with multiplicity 3. So the 0 at x equals to 3 means you're going to have a factor x minus 3. And multiplicity 3 means to the third power. Now, passes through the point 2, 15. That means that you're also given f evaluated at 2 when x equals to 2. Your output y value better be 15. Those are the information that you're given. Okay, so after you set this one up, all you have to do is find the value of a, and then you're done. And you do not have to sketch. You do not have to multiply out the factors. So leave your answer the way it is. Now, how do you find that a? We're going to have to use the fact that f of 2 equals 15. So let me just compute f of 2. So this is going to equal to what? A times 2 minus 1 squared. 2 minus 3 to the third. But f of 2 equals 15. So I'm going to set this guy equals to 15. Okay, now let's simplify this. So what do we got over here? Oops. You have a times 1 squared times negative 1 to the third equals to 15. So 1 squared is positive 1. Negative 1 to the third is negative 1. So it looks like we're going to have negative a equals to 15. So that implies that a is negative 15. Okay. Now rewrite your function. So therefore, our polynomial function f of x is negative 15, x minus 1 squared, and then x minus 3 to the third power. And do not multiply it in. Just leave your answer the way it is. Okay, there you have it. Okay, number 4. Given the polynomial f of x, use the rational zero theorem to list all the possible rational zeros. Okay, so let's do this. So we're going to have to find all the possible p over q's, where p is nothing but the factor of constant term. And then q is the factor of the leading coefficient. Okay, so with that said, what do we got? Q is what? Plus or minus 1. Yay! All right, so that one was good. But P is 80. So we got a lot of varieties here. So let me just list out the P. Well, Q is going to be just plus or minus 1. All right, so P is going to be plus or minus 1. Well, 1 times what is going to give us 80? That's what? Plus or minus 80. Let me just write it on the bottom. Okay. Now 2 is going to go in. So I'm going to have plus or minus 2. Now 2 times what gives 80? 40. So I'm going to write directly below. 3 is not going to go in. 4 go in? Yep, it does. Plus or minus 4. So here that means you're going to have plus or minus 20. All right, I believe 5 is going to go in. Plus or minus 5. Okay, and then what then? Plus or minus 16. 16 times 5 is what? 80, right? Yep. All right, and then what else goes in? 6, no. 7, no. 8. And plus or minus 10. I think that's pretty much it. Okay, so those are the possible values for P, and the Q is going to be plus or minus 1. So all the possible rational zeros are nothing but P over Q's. So what you need to do is what? All you have to do is list out everything that you got as a P value. So here you're going to have plus or minus 1, plus or minus 2, 4, 5, 8, 10, 16, yikes, Okay. Here we go. Okay, so let's look at part B. Find all the remaining zeros, real or imaginary, algebraically. Give exact answers, no decimal approximations. So in this case, the best bet is this. You have your calculator. So first, try to find a zero of that polynomial f of x. So if I plugged it in 1 plus or minus 1, it did not work. Plus or minus 2, I got a little excited, but that didn't work. So I'm going to plug it in positive 4, and then I think I will get lucky. So let's take a look at f of 4. All right, so type that in the calculator, which is what? 4 to the third plus 5 times 4 squared minus 16 times 4 minus 80. And you should get a 0. Okay, so that means what? X minus 4 is a factor of f of x, or 4 becomes a 0 of our f of x. So that implies that x equals 4 is a 0. And x minus 4 is a factor of f of x. Oops. Okay, so that means what? If x minus 4 is a factor of f of x, you should able to divide our given function f of x by x minus 4 to get 0 as a remainder. So to find the rest of the zeros, use that first 0 that you got, and I'm going to use a synthetic division on this, and I'm going to write down the coefficient on f of x, which is 1 x cubed plus 5 x squared, and then minus 16x, and then minus 80. Okay, now I'm going to drop down 1. 1 times 4 is 4. Add vertically, you get 9. Now 9 times 4 is 36. Subtract 16, you're going to get 20. Now 20 times 4 is 80. Add vertically, as we expected, the remainder should be 0. So our f of x, this tells us that our f of x now becomes, remember, x minus 4 was a factor. Now 1, 9, 20. Now that indicates that you're going to have 1 x squared plus 9x and then plus 20. Okay, so I think we're in good hands now, because I believe that x squared plus 9x plus 20 can be factored. So that way we can easily find a 0. So here, what do we get? xx plus plus, how about 5 and a 4? That work? Yes. All right, so here is our function f of x. Okay, so let me just box that. So by looking at this, you should be able to find all the remaining zeros. Okay, so the all remaining zeros, well, 4 was a 0. Now set x plus 5 equals to 0. That means what? X equals to negative 5. Set x plus 4 equals to 0. That means x equals to negative 4. So you have 4, negative 5, and negative 4, and those are our zeros. Okay, if you have any questions, please let me know.